Regression wisdom number 2, correlation regression wisdom number 2, has to do with how the slope, y-intercept, standard deviation of the residuals r, which I forgot to write here, and r squared are influenced by outliers. Correlation and the least squares regression line are not resistant to outliers. However, we have to distinguish between outliers that are influential points and outliers that are not influential points, and that has to do with something called leverage. So first of all, there are two types of outliers: a point that doesn't fit the underlying pattern in the data, or a point that is simply far away from the rest of the data but actually does fit the other underlying pattern. An outlier may or may not be an influential point. So here's what we mean by leverage. Let's say we have a little teeter-totter here. I'm actually going to draw two of them. And let's say this fulcrum in the middle represents the mean of the x values. If I have a point that's far from the mean of x and I sit it on this teeter-totter, it is going to make this teeter-totter tilt this way. So instead it's going to look more like this. If I put a value though right above here on the fulcrum, the teeter-totter doesn't tilt, it stays about the same. So we can see this same thing in a StatCrunch applet. So here we have a regression line drawn through a set of data. Now I'm going to use this cursor to represent another point. So if I add a point up here and I move this point, notice how it affects the slope of the regression line a great deal by moving this point up and down. But if I were to take the point over here instead, see this little light gray line here is the mean of the x values. So if I were to put a point up here and move it up and down, notice that it has very little effect on the regression line, particularly on its slope. Its slope barely changes at all, and the y-intercept only changes slightly. But if I go far away again from the mean of x and I move a point up and down, notice how it affects the slope of the line quite a bit. That's what's known as leverage. So an influential point is a point that if you were to remove it from a set of data, the slope of the linear model would change significantly. The point might not have a large residual because it tends to pull the regression line towards it. An influential point must have high leverage and be inconsistent with the trend of the rest of the data. Note, a high leverage point that follows the trend of the rest of the data does strengthen the correlation, but it's not always an influential point because removing it might not change the actual equation or the slope of the graph, the linear model, very much at all. So we're going to look at a few examples of this. So here we have 3 different scatter plots, and all of which have a point A that is an outlier of some type. And we want to determine if point A is also an influential point. So something can be an outlier without necessarily being influential, or it could be both. Also notice that in number 1, A has a bit of a residual, but not huge. In number 2, A has a very large residual, and then number 3, A has almost a 0 residual. So we're going to look at these scatter plots and see what happens when we remove A and determine if it's an influential point. So I'm going to have to draw something kind of similar looking to what I have. I can't exactly draw what I have, but in the first one I have something that looks like this, and then here I have value A, and then I have my regression line. Okay, so that looks pretty similar to what I have. Now, what happens if I remove A? Is it an influential point? Quite influential. Not only does my correlation change from positive to negative and also lowers the correlation, also, and I guess I didn't actually look at the correlation, so I'm going to put this back and see. The correlation here is 0.746. So when I remove this point, the correlation changes to negative 6.6520, and the regression line changes quite a bit. So if we were to write this here, let's go ahead and see what happens if we cross this out. This is the new line that we get. So 1, the correlation goes from positive to negative. The slope changes drastically. So the equation of the line changes drastically. So A is an influential point. Okay, and number 2, let's take a look at this one. So I'll clear this off. Here we have kind of scattered points all along here. I'm not sure how exactly, and then we have this point that's sort of right up here. Okay, so there is my least squares regression line. There's the correlation coefficient, 0.7683. Okay, so we're going to see what happens if we remove point A. Notice the correlation is strengthened, but the equation of the line didn't really change much at all. I'll kind of put this point back, and you can see not much of a change. A slight change, but not much. So we would say A is not an influential point, and it's not influential because it's directly above x bar. It's not very different from its x value is pretty much right in the middle. So if we remove this, this is directly above x bar, or at least close to directly above x bar. So when we remove A, the correlation strengthens. Now that doesn't make it an influential point. It does strengthen the correlation when we remove it, but the equation of the line, its slope, barely changes. So it's not an influential point. So A is not an influential point. Now the reason why is it is not high leverage. It's not high leverage. It's too close to the mean. It's close to x bar. All right, so it's close to the middle of the data in the x direction, so it's not an influential point. Doesn't change the slope of the line much. Okay, so let's look at number 3. Also, I just want to point it out, it does have a very large residual, but just having a large residual doesn't make it necessarily an influential point. All right, so let's take a look at this one now. Okay, I think that's similar to what I had. Let me double check that one to make sure it is similar to the one that is on the picture. Okay, close enough. It's kind of the same idea. Okay, so notice we have a very high correlation of negative 0.926, almost negative 1, very, very strong. Now, if I were to remove point A, notice point A has a very small residual, but it is an outlier. So the question, is it an influential point? Okay. It weakens the correlation when I remove it. But did it change the equation of the line much? No, not much at all. So it is not an influential point. So if we remove this, even though it has high leverage, it's so much in line with the rest of the trend of the data that the trend of the data does not change, even though it's a high leverage point. So we have the correlation weakens when we remove x. Equation of the line barely changes. So A is not an influential point. So I want you to notice that once again, this is high leverage. This is not high leverage. This is high leverage. So just because it's high leverage doesn't make it an influential point. This is high leverage, and does not follow the trend of the data. So an influential point must have high leverage and be inconsistent with the trend of the data. And inconsistent with data, with the rest of the data. So that's what makes it an influential point. This is high leverage, but follows the trend of the data. So that makes it not influential when we remove it. So you have to, so how do you figure out for sure if something's influential? You can guess if it's influential if it's got high leverage and it's different from the trend of the rest of the data. Sometimes it's real obvious. Sometimes you kind of just have to remove it from the data and check it out and see. So back to summarize then, correlation and least square regression lines are not resistant to points that are influential points.